Technology changes at a breathtaking pace. More powerful chips, thinner machines, sleeker outer shells, but inside, one thing has almost refused to change its color. Whether it is a supercomputer or a cheap toy, the same familiar patch of green keeps appearing. So, why, when we are fully capable of making circuit boards in mysterious matte black or vivid red, does green still hold on so stubbornly? The answer is not about aesthetics. It lies in how circuit boards are protected, how they are inspected, and how an entire industrial system slowly locked itself into a single standard. Welcome to Everyday Things Explained. What we're really looking at. First, we need to correct a common misunderstanding. What you call a green board is not actually green at its core. The core of a circuit board is usually FR4 material, a fiberglass base reinforced with epoxy resin. By nature, it is pale yellow or dull brown. That bright green color you see is actually the solder mask. Think of it as an extremely thin, insulating coating, but one with absolute discipline. It is not applied for beauty. Its vital job is to shield and protect the copper traces from dust, moisture, and oxidation. Most importantly, it prevents molten solder from flowing into unwanted places during manufacturing. The phenomenon engineers call a solder bridge. A modern circuit board is not just a place to mount components. It is a surface that must be controlled with precision down to the micrometer. Why green fits so well into the factory? So why is this protective layer green? The first reason lies in the interaction between the material and our eyes. During manufacturing, circuit boards must go through extremely strict inspection. Green creates the most effective contrast against shiny metal pads, silver solder joints, and white printed markings, the silk screen. Technical documents from Altium note that colors like black or blue offer far lower contrast, making error detection a miserable task and causing visual fatigue very quickly for manual inspection engineers. According to standard CIE photopic vision data, the human eye reaches peak daytime sensitivity at wavelengths around 555 nanometers, right in the yellow-green region. Green is not some mystical color that relaxes us, but it is the color in which the human eye can pick out detail most easily, spot defects most clearly, and remain stable enough to be repeated millions of times without inviting mistakes. How a color became an industry standard. But here is the deeper reason of all. Once the factory had been optimized for green, everything began to lock itself around it. According to Eurocircuits, the earliest practical solder masks were green by default, and in the early days, there were almost no other choices. When the electronics industry exploded after the war, military and defense industry standards pushed green into mass production. NCAB explains that different colors require different processing parameters. White or black inks often transmit light less effectively than green. That directly affects exposure time and the resolution of the mask. With green, manufacturers can create protective bridges between component leads, solder dams, with a minimum width of just 0.1 millimeters, while still maintaining reliability. And once green material was always in stock, once the machines were already tuned for it, and once every inspection workflow revolved around it, green was no longer a choice at all. It became the industrial default. Why it is still green today? In industry, what wins is not what looks best, but what creates the fewest errors and costs the least. Green remains the option with the least friction. Other colors only appear when a brand wants to leave a distinct visual mark, like Apple's black circuit boards, or when a product has a specific application, like white boards for LED lighting, to reflect light more effectively. If you are building a DIY product, choose green for better pricing and easier inspection. Only choose a striking color when you truly need display value and are willing to accept the higher cost. Green was never just decoration. So the next time you look at a green circuit board, you will no longer be looking at some lifeless default color. The thing that lasts the longest is usually not the most glamorous one, but the one that is stable enough and good enough for the whole world to cling to. But look, while green took 70 years to dominate, just outside that outer shell, another ruler is clearing away dozens of old connection ports. Why does a tiny socket, thin, fragile-looking, and reversible from either side, have the power to force even the largest technology empires to surrender? Does the secret lie in symmetrical design, or in a deeply complex electronic brain hidden inside? The story of USB Type-C will leave you amazed at the true cost of convenience. Are you on Team Practical Green or Team Minimalist Black? Let me know your pick in the comments. Thank you for watching. Stay tuned for the next secret on Everyday Things Explained. See you again.